Guys, Mr. Schwanenkamp, just wanted to get you some learning in while we're not together. I know we are all sad about the whole thing. We wish we were in math class right now. It would be better. Today, we are worried about chapters, first semester, chapters 1 through 3. We're going to go through all of those things today. We're going to fill out some notes for the most part, just kind of remembering some stuff. Nothing that will be too difficult for you, I don't think. A reminder that we have a bunch of resources here on Schwann Academy. Down here, these are all the things we did first semester as we reviewed for the final. So obviously, if they were on the first semester final, that would be pretty important. Dev, there's some 4 corners if you need it. I'm sure it's been a while since you've done it. And then below, you've got videos with the doodle notes. You have all those notes. So if you pulled those out, probably not the end of the world here to go back and look at, because they would be pretty helpful to you. There's an answer key through a bunch of stuff, things like that. So that's a lot of resources for you. Remember what you're turning in here in the next couple days. You've got a Padlet that you're doing and a Quizzes. That Quizzes is kind of just random review over graphs, so you might want to look at that a little bit. If you missed a question, who cares? I'm not trying to say, "Ooh, you missed questions," or "No, you didn't." I am just trying to get to the point where we start to learn stuff a little bit. Oh yeah, that way you get to see my beautiful face this whole time, even though I'm definitely not going to teach with my camera on. All right, so we are looking at this guy right here, chapters 1 through 3, quick review, blank. There's the key right there, but I'm going to work through it, at least somewhat quickly through it with you to see what we know. So we're looking at this. We're going to that front page. All right, here we go. So we're talking about definitions a lot on the top, and we're going to do some problems here together. I might jump around a little bit and not do everything, but you've got the answer key so you can see it. When we talk about continuous is something they would definitely ask on a free response question. When we say continuous, we have to show that the left, the middle, and the right are all equal to each other. Continuous means you don't pick up the pencil, but we need to show left, middle, and right. Remember how we do that. So if we wanted to show that we're continuous at 1, limit as x approaches 1 from the left of f of x needs to be equal to f of 1, needs to be equal to the limit as x approaches 1 from the right of f of x. That is how we show continuity. So remember that if you've forgotten, but that is definitely key. Differentiability. So differentiability means you can find the derivative. There are 3 main spots where we can't be differentiable. A graph is not differentiable when it has a corner, a cusp, or vertical tangent. Vertical tangent line means like, hey, my graph does something like that. We're at that spot right there. That's not even vertical enough. For a moment in time, my graph goes vertical. Not very often that happens. The other thing that has to be true for differentiability is you have to be continuous. If you're not continuous, then you are not differentiable. Okay? Remember, you have to be a smooth, continuous line in order to be differentiable. That's what we're looking for. Horizontal asymptote is the same thing as the limit as x approaches plus or minus infinity. So if I had a graph over here, it would look something like that. That is a vertical asymptote right there. That is a vertical asymptote right there, because if I continue going that way, it's going to keep being the same number. Remember, you can cross lines. So if I drew a line that looked like this, that went, it got closer and closer to 0, then you have a horizontal asymptote at y equals 0. Intermediate value theorem. Intermediate value theorem is similar to the concept you were 2 feet tall at 1-year-old. You are 6 feet tall at 18. Were you ever 5 feet tall? That is intermediate value theorem. So remember, there are 5 major components that you needed there. We had to state your interval. So our interval was from 1 until 18. Those are my x values. Okay. I needed to state my end points. And so my y values, so 2 to 6. So I stated those things. I need to state IVT. If you're going to use intermediate value theorem, you got to say intermediate value theorem. That's the third thing. And then we would need to say the fourth thing, which is you have to be continuous. If you don't say continuous, IVT doesn't work. And then the fifth and final thing is just proving to someone that, yeah, 5 feet falls in between your two endpoints. So just saying, hey, and 5 feet is between 2 and 6 feet. That is IVT. Don't think of it as this big, crazy theorem that has a lot of letters. Think of it in terms of that it's a pretty simple concept that you just got to put things together. Okay? Limit, the function is approaching the same number from left and right. That is a key. Make sure you understand that it has to be approaching the same number from the left and right side. Don't try to split it up. And so just looking through things, remember how we do this. You take -3, you plug it in. If you take -3 and plug it into this first one, you get 24 over 0. If I get it all over 0, it's DNE. All right. Something else, like on this one, if we're doing x to the fifth and x to the fourth, remember if we're plugging in infinity, it would be a big number on top, but it'd be real big on bottom. And if it's real big on bottom, it's going to keep growing and growing and growing on bottom. And if it keeps getting bigger on bottom, you're going to get closer and closer to 0. Remember, you got to check to make sure we're not always getting 3. Something like this, if you get 0 over 0 or 0 over 0, you can use L'Hopital's rule. That is always a very helpful technique, using L'Hopital's rule to figure it out. There's not one like this, but let's look at it anyways. So like the limit as x approaches infinity, that's an infinity sign, of 2 to the x over x to the 1,000th power. And so our rules don't work where where's the bigger exponent, except they kind of do. Where's the bigger exponent? The bigger exponent is definitely on top, because if I plugged in infinity on top, it would be a really big number. 2 to the infinity power is bigger than 2 to the 1,000th power, okay? Because infinity never stops. This would be bigger, so it would never stop growing its DNE. What about the limit as x approaches negative infinity of 4 to the x over, well, let's do e to the x just because we're more familiar with that, x squared. Well, think about what e to the x looks like at negative infinity. This is an e to the x graph. So at negative infinity, it would be 0 over a giant number. That would be 0. Just be careful with those things. Think it through. You shouldn't be too bad. Remember what this graph looks like? It's been a minute since we've done it, but it's this graph right here. If you don't remember, plug in some numbers, see what you get. But it looks like that. So think about what the limit would be at 0, and so on. You can do graphs. If you're trying to decide if something is continuous, you want to see the limit from the left and the right. Which one of these equations would tell you the limit at 1? This one, because we don't care about what happens at 1 if I'm doing the limit. I want to know what's happening around 1. So that would tell me the limit. To see if they're continuous, I would want to see if these two things are equal, because this is going to tell me the limit. That's going to tell me the value. Together, it will tell me if I'm continuous or not. Let's go through one more page here in this video, and then we'll move from there. A critical point, remember, is where, and we're just doing basic definitions, so these weren't necessarily in this chapter, but this is just things you need to know. A critical point is where the derivative is 0 or undefined. Okay, 0 or undefined. Remember that a critical point is simply a place where a maximum or minimum could happen. It doesn't mean it's going to happen. It just means it could happen. Okay, so let's talk about derivative. There are 1,000 different ways to say derivative. Try to brainstorm some of them, but hopefully you're thinking things like f prime of x, y prime of x, or not y prime of x, just y prime. Slope at a point, instantaneous, rate of change. I'm going to abbreviate because I don't want to write. Dy over dx, slope of a tangent line, velocity, the limit definitions. So remember the limit as h approaches 0 thing of f of x plus h minus f of x all over h, those kind of guys. There's a bunch of different ways to say derivatives. Don't forget them. Extrema, where extrema happens. Extrema can happen at all critical points. Okay. Extrema can happen at critical points or end points. That's where can you have maximums or minimums. Maximum minimums, especially absolute maximums or minimums, happen at end points and critical points. Don't forget that. Mean value theorem. Mean value theorem, you've got to be continuous and differentiable, but it's something along the lines that if your average rate of change is 2 on an interval, then there has to be some time on that graph. If the average rate of change is 2 on an interval, then derivative must be 2 on that same interval. So what does that mean? Well, it means, hey, I drove for 2 hours from 10 a.m. till noon. I averaged 60 miles per hour. Okay, average rate of change means slope. So I averaged 60 miles per hour. In those 2 hours, I drove 120 miles, so I averaged 60 miles per hour. Was there any time during that 2-hour interval that I was actually going 60 miles per hour? Yes, there has to be, because of mean value theorem. Product rule, first times the derivative of the second plus second times the derivative of the first. Don't forget about that one, Jason. And then quotient rule. Quotient rule is low d high minus high d low all over that low. You know how to take derivatives. I'm not going to do any of those for you. Things like quotient rule. Don't forget about the derivatives of things like tangent and secant and some other things. Look back over those table things. Don't forget what type of rule are you going to need for both of those. Kids will skip them, but you need to know those rules. First 2 chapters aren't too bad. We will get more complex as we go, but that'll get you started. I will see you at the live sessions when you have questions. I will add a video for the second half of these notes here in the next few hours or so. So if you're seeing right now and there's not on there, I'll get to it. Have a good day, stay safe, and I will see you guys soon. Thanks, guys.